Today, I will be talking about the Earth's magnetic field and how the Aurora Borealis is formed. The Aurora Borealis, also known as the Northern Lights, is basically a colorful display of dancing lights that we generally may see near the geographic North Pole. These lights are produced when charged particles that come from the Sun strike the atoms and molecules located in the Earth's atmosphere. After absorbing huge amounts of energy, the atoms become excited and emit various forms of light in different colors. Here are the variety of colors that we may see. The green color comes from the oxygen atoms, and the blue, purple, red all come from the nitrogen atoms that are located in the Earth's atmosphere. The moving molten iron in the Earth's core, which not only produces a constant electrical current, but it also produces our planet's magnetic field. This clearly demonstrates the principle of electromagnetism, which states that moving electric charges create a magnetic field. An interesting fact to know is that Earth's geographic poles are actually 11 degrees away from the magnetic poles. Not only that, but the true magnetic South Pole is actually near the geographic North Pole, which is why the north side of the compass points towards the north. Also, our magnetic field is constantly becoming weaker and weaker every day, and so this tells us that we will soon be experiencing a complete magnetic pole reversal. Right now, the poles are shifting at a rate of 41 kilometers per year. Now that we know more about Earth's magnetic field and the Aurora Borealis, I will now explain how it's formed. Well, it all happens when charged particles moving in the Sun produce an electrical current in the star's magnetic field. An interesting fact to know is that the equator of the Sun is actually moving at a faster rate than its poles.
Travel from the poles of the Sun towards its equator, and you'd notice it turns faster. Analyzing sound waves inside the Sun reveals that the plasma layers beneath the surface also spin at different
The Sun's
speeds.
rotation is not constant throughout its entire area. The magnetic fields are constantly twisting and colliding with one another. Occasionally, these charged particles, also known as plasma, force the field lines to come to the surface of the Sun, where they will twist and collide with one another, sending about billions of tons of energy for what is known as a CME. The CME stands for coronal mass ejection, and it takes around 2 to 3 days for it to reach Earth. The moving charged particles ejected from the Sun consist of protons and electrons. This current of electrical charges is moving perpendicular to its own magnetic field. Therefore, the magnetic force alternates in directions back and forth, according to the right-hand rule. Once these charged particles strike our planet's magnetic field, the two magnetic fields converge and drag the fields to the opposite side. While this happens, the charged particles become trapped between the field lines, and so due to the magnetic field, the particles start moving in a circular motion. This is because the magnetic force acts as a centripetal force, and the force pushes the particles towards the center at all times. The field lines actually accelerate the particles, causing them to gain more energy, which allows them to travel up the magnetic field till it reaches the top, where the Earth's gravitational field brings it back down towards the pole.
Allowing charged particles to zip back down the field lines toward the north and south poles. Extremely powerful storms distort the magnetic field even further.
It's constantly pushing on the plasma draped on the field lines, billowing them out like sails pulling on a mast. Like solar flares, when magnetic lines cross, there can be an immense explosion. In this case, the lines are cut and the sail whips off into space. Loaded with 1 billion tons of highly charged plasma, the CME waves hit with full power. The charged particles funnel down into the atmosphere, electrifying it like a giant neon sign, producing dazzling aurora displays. The storm is so intense, Earth's magnetic field all but collapses. Millions of tons of plasma spill towards the equator, and a powerful electric surge pulses over the globe. For the largely pre-electrified world, the moment passes with minimal damage.
Even though when a CME strikes our planet's magnetic field, it treats us with the Aurora Borealis, these charged particles aren't always pleasant to Earth. Our Sun is capable of ejecting a very large CME, which could potentially strike Earth and destroy all our satellites and our power grid, as these charged particles contain too much energy for our man-made objects to handle. Especially with Earth's magnetic field getting weaker and weaker every day, the chance of this risk is increasing. This means that we could potentially be without power for days, weeks, or even months, and our lives could be at a huge risk.
When this happens, technology like long-distance power lines can become overloaded.
It can cause damage to transformers at either end of the line. In fact, in 1989, most of the Canadian province of Quebec blacked out because a transformer was blown out by a solar event.
If we have that storm that hits our communication system, it hits our power companies and all these things that we depend on, there's all kinds of chaos that can lay out there.